our.NET user group. My name is Curelet-Balan. If you haven't been here before, I'm the user group leader. There's Ken Centerelli in the front. He also helps co-organize our meetings. So if you ever have any questions, feel free to reach out to us through our meetup group. So tonight we're doing lightning rounds, which is awesome. So it's going to go fast. We have 4 topics to get through. Each are 20 minutes. The last topic's going to be half an hour. So we'll do 2 topics, then take a break, then do the last 2 topics, and then do a wrap-up, draw for prizes, and then you guys are on your way. So tonight's session is brought to you by Code Connect. I don't know if many of you have met Josh Barty. He owns Code Connect. They sponsored our September to November .NET sessions. So thanks to that company, they're awesome. I also have an Alive license to give away, which is a Visual Studio extension that his company's developed. Also thanks to Microsoft, and then our swag sponsors, JetBrains, Ozcode, Reflect Software, Telerik, Infragistics, Pluralsight, DevExpress, Code Magazine, O'Reilly, and MSDN for all being awesome swag sponsors of our group. Okay, and if you love to tweet, use our hashtag CTTDNUG. Definitely let us know how we're doing. Go online and rate the meetup afterwards. Tell us what you liked or what you think we could do to improve the sessions. If you're looking for jobs, there's a job postings board on our meetup page. Go to the discussions group. If you have job postings you want to advertise for your company, put them up there. It's free. You could just add job postings as you want. Definitely do that. But as soon as the job posting's filled, take it down, or let me know and then take it down. And we're always looking for more sponsors for upcoming sessions and upcoming events. We have a Windows IoT event, or Windows 10 IoT on the Raspberry Pi event. Blair from ObjectSharp is going to be presenting that. He's got some really cool demos. You're going to get a little taste of IoT tonight with Keith. So that's going to be awesome. That session's at the Central Library in downtown Kitchener. So that's going to be our last session before the Christmas break. Then we won't reconvene again until January. Then there's the London.NET Developers Group. They have a Windows 10 session coming up in December 3rd. HackerNest is always an awesome group to be part of. I love going to their social nights. Their next one's in January at Sandvine. And there's a bunch of ladies groups in town. Ladies Learning Code, Girl Geeks Dinner, KW, they've picked up again. Women Powering Technology and Leading KW. And I believe Leading KW is meeting this Saturday. They meet once a month. So that's available there. And if you have kids, there's Year of Code Waterloo Region. They're doing a big push to help kids learn how to develop. There's also Kids Learning Code in Toronto, but schools should now be running Hour of Code. So if you have a child that's in an elementary school or in high school, ask the teachers if they're getting someone in to run an Hour of Code program. Because it's all the content's online and available. The teachers just need to download it, go through the material with the kids for an hour. It's pretty awesome.
If they're not, do it.
If they're not, then do it with them at home.
Or do it at the school, volunteer?
Yeah, I can't.
No, I mean.
But yeah, parents, you're more than welcome to volunteer. To help. All right, without further ado, we're going to get started with our first topic.
Okay, so my name is Keith Ma. I'm an application developer at Trojan Technologies. So this topic has nothing to do with what I do day to day. Actually, I'm going to do this a little bit backwards. What I'm hoping to do is just give a sense that IoT is actually something you've probably already been doing, and it's actually pretty straightforward. It's just a different way of thinking about what you've been doing. I'm just curious, any amateur radio people in the group? Oh well. So, let's go to this. What do other people think IoT is? Sure.
Connected devices that send data to a cloud or some kind of database.
Okay. And that's actually the way I'm going to present it as well. Connected devices, and basically just things are just connected everywhere. It's so from your smartphone or whatever you've got, and it's just a lot of data to be analyzed. Depending on how you like to think of things, the IEEE, the Institute for Electrical Engineers, actually has a group that's trying to define what IoT is. And I've actually got their link to their definition site on the screen right now. So, that's weird. Basically, those are three very simple devices or sensors. There's on the left, there's actually a push button, but you can't quite tell that. In the middle, there's a temperature sensor, and on the left is just a regular LED. The temperature sensor, basically, there's 3 pins on it. There's one for ground, one for power, and the middle one's actually the data. And the LED is just 2 wires just passing the current through. So for most of the devices we work, or I've been playing with, it's basically the devices transmitting data to the computer, server, whatever. There's basically four different ways to, or four patterns that we normally deal with. The second one on that list is the device is asking for data, or just trying to ask the question from the server. The third one is basically the server sending a command out to the device to do something. So whether it to be turn on a light or turn things on and off is probably the most common. And notifications, just like on your cell phone, you want to alert somebody to something. So the temperature's fallen too low in your house, the furnace is probably bad, you can send a notification out. So that's actually the Raspberry Pi that I've got hooked up here. I'm assuming most people have seen them before, or have heard of them. Well, it's just a very small, almost credit card sized computer. There's actually four USB ports here. I'm actually plugged into the Ethernet port in my case. There's an HDMI port there, and power goes in there. There's actually a micro SD card slot underneath there, which is where you boot up from. And we'll be looking at the connectors across the top, which is how I'm connecting into the breadboard that I have sitting up front.
What kind of onboard memory is there, apart from the SD? Is it all over the place, or different?
This is the 2. I think it's got a gig on it. 1 gig on it. So it depends on which model you buy, and depending on what you need, like there's also Arduinos which come with various configurations as well. So the connector looks like that. So there's 40 pins, and you can get power from a couple places. There's actually, I guess the one important thing to note is there's actually 2 ways to identify each pin. There's 40 pins, and you can see them numbered with a green background. But in some cases, they actually refer to it by the names. So GPIO2 through, and I'm actually going to be referring to things by the GPIO number. There's also, depending on the model of Pi you've got, they've actually changed a couple of pins, at least the names for them. So if you're looking at documentation, it might be slightly different than what you're actually looking at. So the circuit I've actually got built here is sometimes called Linky, sometimes it's called Hello World. It's probably one of the simplest circuits we can build. I've only put one light in mind, so ignore the blue light and the blue wire, I guess. So basically, I've got power coming out and into the breadboard, and the black cable is or wire is ground. There's an LED and a resistor, and then this purple line, which is purple, going into GPIO pin 17. And that's going to allow me to control the light, just turn it on and off. the code side is actually pretty simple. This is actually in Python, and all I'm doing is loading the key libraries. As I mentioned, there's 2 ways to number the pins, so I'm telling you that I'm going to use this particular method. Setting pin 17 to be an output node, because it could be input or output. And all I'm going to do is send highs and lows to the pin to turn the light on and off. So, if this is going to work for me. Here it goes. That's the same code that I was showing you earlier. Don't know if it's actually legible or not. It does turn out that you need to be privileged in order to run this, to actually talk to the device. So, on the touch mode, you can currently see that there's a blue light blinking. See if this bit's gonna work. Okay, this worked earlier. Okay.
Are you connected to the network?
No, it's all done through USB.
Oh, okay.
And I tried it like just before coming here, and it was actually working. But I guess we can try to hold it up. But there's just basically a couple wires and a blinking light right now. So my attempt to connect the camera failed. So there's basically, the easiest way to think of it is there's two basic data types that you interact with the devices with. There's digital, obviously, because we just looked at that, on and off. And there's analog, which is normally just bytes, integer values as bytes. So if I'd connected up the temperature sensor, I would send it a request to get the temperature, and it would actually send me a sequence of bytes back, which then I'd have to decode. So fundamentally, it's much the same as the code that you see for the blinking light. It's just that I would essentially open up a file to receive the values back. And if there's basically a data sheet that comes with, or you can get for the device. For that particular device, it was 28 pages long, I think it was. And it'll tell you everything you ever want to know about that device, how to wire it up, how to interpret the values, what to send the device to get a response back. As it turns out, that one will return like up to half degree Celsius accuracy, and the bytes break down to give you the decimal point, the integral part. And I guess just read the documentation. They tend to be very well documented, so sometimes better than the software that we normally deal with. So the other interesting thing is, at least for me, I'm interested in the data I can get back and what I can learn about what's actually going on. So I found an interesting video. I think this was on the Microsoft website. It's advertising the Cortana Analytics Suite, and it's actually for the North American Eagle, which is basically a jet vehicle that they're trying to break the land speed record with. And they say they've got just over 30 sensors producing 12 million data points, and that's over about a mile at, I think it was 440 miles per hour. And they say that's going all up into Azure, but I'm assuming it's cached locally and then sent up later for analysis via machine learning or whatever it is they're doing. I've got, as Ken noticed earlier, a motion sensor here, which is, I guess, basically just another camera, but it's a bit more complicated than the blinking light and the temperature sensor. But ultimately, you still deal with it just like you do any other application. These work. I suspect the problem is with the USB hub.
Some of those connection walls there.
It's okay. Usually done fine. Well, I know what the problem is. I said I'll have lots of wires. Never plug in the hub. There we go. So this is just for me where you would do a little sensor. Or 2 volts. And sometimes that's just seeing numbers. Sometimes it's sometimes it's just finding a different way of looking at the data that really makes things come to life. So in this case, oops. It's a sensor. There it is. It actually renders where my fingers are. And you can see why it gets interesting, because the camera can't actually see my thumb. So it's guessing at where it is, and it's actually incorrect right now, because it's actually hidden underneath. My hand is actually covering my thumb. So that's where things get really interesting for me. There's all this, I guess, what we call big data coming in, potentially. And then learning about what the data is going to tell you. You can get the data from the car. This is all the stories we've had this summer about people hacking into cars and planes. I've actually got a trouble light on my car right now for the emission system. It keeps going on and off. It'd be neat to put in a logger, collect the data, and see if you can figure out what the pattern is. Ideally before I have to get my emissions tested next year.
Is it a Volkswagen?
No. The dealer checked and they said there's no problems with my emissions other than I'm getting the light on. So, so speed up. So I'm just going to go to a really large scale example. This is the Shell Pearl gas to liquid cell plant in, I guess that's the UAE because it's outside of Doha. You can get an idea just from the picture of how big it is. Basically, there's 1,000 cabinets for all the sensors to come, controllers for those sensors to come into, and 200 computer servers to deal with all that data. This is a production plant, so there is a bit of redundancy. It's not the sensors that I'm showing here. It's actually much more complicated. The networks are redundant. The servers are redundant. Because you really don't want to lose control or not be able to control the plant. And apparently there's 6,000 kilometers of cables just to hook everything up. Actually, the reason this is just stuff I've pulled off the internet. The reason I picked that plant is it actually just initially came online in 2010 and went completely full production in 2012. So it's actually a really new plant. So it's not like this is the way it was done in the past, but there's a lot of planning involved in trying to make sure you have the right data for what you want to do. So it's just a picture on the right of what a control cabinet might look like, and a control room. I've stolen those pictures off the Honeywell website, so it's architecture or marketing material. Some applications, always optimization is nice. You can always make things better or try to make things better. Failure avoidance, you don't necessarily want downtime. I actually brought a bag of potato chips to use as a prop. Almost all the food products have a best before date that's printed on them, so the bag itself is pre-manufactured, but there's something that prints the best before date and usually a timestamp on it. And bag of potato chips, who knows how many they actually produce per hour? If the printer goes down, that's a lot of money that's being lost. So if you can predict when the printer's going to fail and to arrange it so that you can get somebody there so it's only down for a minute as opposed to half an hour or an hour, that's a lot of money you can save. That's kind of ties into the predicting the future aspect as well. Some opportunities and challenges. Interoperability is always an issue, especially at the more of a consumer side of things, because you've got the Apple HomeKit versus Google's Brio. They're all slightly different, and they don't necessarily talk together. Nest has something called a protocol called Weave, as does Google, and they're not the same. Microsoft is promoting Android currently, and that's actually closer to Nest's protocol. This is just from reading, I haven't actually tried it. User interfaces are always a challenge. You've got some small devices with no keyboards. How are you going to enter all the Wi-Fi keys if you're using Wi-Fi? If you're selling a house, do you rip everything out? How do you know that the previous owner, if they left it there, hasn't left something there that's going to tell them about what you're doing? Don't know. So, I think I'm squeezing in under the wire. So basically, what I was trying to describe is IoT is already out there and around us. Your car, a smart meter for the electricity in your home. And programming is not that different, especially if you've been doing the mobile applications. It's limited resources and you're just interacting with devices through an API. It's really more a question of what's the application you want to build, as opposed to how hard it is to, or how easy it is to work with all the devices. How close did I get?
You got 36 seconds left. You take
Okay.
one question.
Any questions?
The visualizer that you had for your hand, was that part of
It actually comes as part with the hardware,
which hardware?
the Leap Motion sensor.
Oh, I see. Okay.
It'll install with the driver, but you can actually get it to give you the images of the hand unprocessed as well as giving you the actual locations. The demo where I showed a web page is actually just a WebSocket and JavaScript talking to WebSocket and rendering HTML. Literally, there's nothing. Okay, I'm done. Literally, there's nothing special about what's going on. It's stuff you're already doing today. Thanks.
Thank you, Steve.